Small, fast, and deadly accurate, a bullet is one of the most precisely engineered pieces of hardware on Earth. Behind every round lies a combination of chemistry, metallurgy, and engineering, all executed under tightly controlled conditions where even a microscopic flaw could mean failure. In this video, we go inside one of the most secure and advanced ammunition manufacturing facilities on the planet to uncover the step-by-step process of creating a modern bullet. From raw materials to final packaging, from sheets of brass and powdered chemicals to high-speed robotics and rigorous ballistic testing, you're about to discover how firepower is forged with surgical precision. This is not just about metal and machinery, it's about safety, control, and trust. Because when a bullet is fired, there's no second chance. Coming up, what materials go into a bullet and why each component is critical to performance. Before any bullet is assembled, it begins as a collection of raw materials, each selected with scientific precision for its role in creating power, control, and reliability. At the heart of every cartridge is the casing, typically made from brass. This golden-hued alloy of copper and zinc is prized not just for its durability and corrosion resistance, but for its ability to expand and contract predictably under pressure. When a bullet is fired, the brass casing expands tightly against the chamber walls, forming a perfect seal to prevent gas leakage, then cools and contracts, allowing it to be ejected cleanly. Massive rolls of brass sheet arrive at the factory, inspected for microscopic flaws before being fed into forming machines. But the casing is only the beginning. At its base lies the primer, a small metal cup containing an explosive compound that is sensitive to impact. When struck by a firing pin, this tiny component ignites instantly, creating the initial spark needed to activate the propellant. Because of its volatility, primer manufacturing takes place in specialized environments, often under robotic control, to ensure maximum safety. Workers in this section wear anti-static suits, and the process is monitored with precision cameras to detect even the slightest error. Once the primer does its job, the fire moves to the propellant, a refined chemical mixture packed tightly into the casing. Today's bullets no longer use traditional black powder. Instead, they rely on modern smokeless powder, typically made from nitrocellulose and various stabilizers. This powder burns cleanly, reducing smoke and residue, and can be tailored for specific ballistic profiles. Every grain of powder is measured with incredible accuracy, because even a slight deviation could alter performance or, in extreme cases, cause catastrophic failure. Finally, there's the projectile, the bullet itself. Usually, it starts as a lead core for weight and density, then gets wrapped in a copper or brass jacket to increase durability, reduce fouling, and enhance aerodynamic stability. These jackets are drawn from copper sheets, shaped with high pressure, and bonded tightly to the lead inside. Depending on the intended use, bullets might be shaped for expansion, penetration, or accuracy, ranging from full metal jackets to hollow points and even armor-piercing variants. Regardless of the design, they all share a common goal: delivering force with precision. Each of these components, brass, primer, powder, and projectile, is engineered independently, but they must work in perfect harmony. Together, they form the anatomy of a modern bullet: a miniature explosion chamber, a propulsion system, and a precision-guided point of impact. The journey of a bullet begins with a simple disc of brass, cold, flat, and unassuming. But in the factory, this raw material is transformed into a critical component through a process that requires extreme force, heat, and precision. The first step is known as cupping, where brass sheets are punched into small circular blanks. These blanks are then pressed into shallow cups through a powerful drawing machine. From here, the cups undergo multiple stages of drawing and annealing, a process that gradually stretches the brass into long, narrow cylinders while carefully applying heat to prevent cracking. Annealing softens the metal just enough to keep it ductile, flexible but strong. Each casing is trimmed to exact length and passed through a washing station that removes residue and oils. They emerge clean, golden, and perfectly smooth. But they're far from finished. At this stage, each casing is run through a series of progressive dies that shape the neck and mouth, form the base, and create the primer pocket with tight tolerances measured in microns. To ensure reliability, every casing is subjected to automated visual inspection. High-speed cameras check for dents, deformities, and thickness irregularities, rejecting any imperfection without hesitation. Only flawless cases move forward. Despite the rapid pace of production, the standards remain unforgiving. A single crack or off-center primer pocket can lead to failure in the field, something no soldier, officer, or sport shooter can afford. By the end of the process, that thin piece of brass has become a highly engineered pressure vessel, strong enough to contain an explosion, yet light enough for rapid cycling in modern firearms.